Here's a video on simplifying exponents when they're written as a fraction or as a division problem. So we're going to have a couple examples here to show you how to properly simplify these. There are no negative exponents in this. Alright, so what we're going to do is I like to suggest, let's break apart each thing, and so I want to have the numbers in their own problem, and then I want to have the letters in their own problem. And then we'll deal with each of those separately. So I'm going to kind of draw a line straight through here and make two new little fractions. So I have 3 over 3, and then I'm going to say times n to the 4th over n to the 3rd. So we just separated the things a little bit from each other, put some space between them. Alright, so when we have numbers in a division problem, that really means divide them. So I'm going to divide these two things. 3 divided by 3 will give me a 1. Okay, that's what happens with the regular big numbers. Now with exponents, what we learned to do is to write out how many they are. N to the 4th means n times n times n times n. And n to the 3rd means 1, 2, 3 of those. So now we want to look and see if I have an n divided by an n, that will result in a 1, or result in not having any n's left in that spot anymore. So these will cross out, that becomes a 1, these will cross out, these will cross out. So I have an n left on the top of my fraction. So I'm going to say n over 1. Okay, whenever there's nothing left on the denominator, it's not 0, I can't have a 0 on the bottom, it's a 1. So all I have left from this problem is 1 times this, which really results in just an n. 1n. Okay? You can write a 1 in front of that as well. Another way to think about this exponent part is think about where are there more n's? The 4 or the 3? Are there more on the top or on the bottom? Well, there's more on the top. How many more are on the top versus the bottom? There's 1 more. So that's another way to think about it. I'll show you that in this next one. So we have another example. I'm going to first separate the numbers from the letters. So the number up here that's not written in is a 1, so that might be helpful. If there's no number, write a 1 in there. So I'm going to separate this. So I have 1 over 2, and then I have my letters, r squared over r to the 3rd. So with our numbers, we want to divide these, but we do not want decimals in our answer. If I take 1 divided by 2, I get 0.5. So a lot of times what you're going to do is you're just going to leave this as a fraction. So this is just going to stay 1/2. Okay? 1 on the top and a 2 on the bottom. So for my variables, or for the letters, I'm going to think about this in the other way I suggested, thinking about where are there more r's? 2 versus 3. Well, there's more here. How many more? 2 versus 3, there's 1 more down here. So really, this is going to result in an r being on the bottom and a 1 on the top. Nothing, but we don't really say nothing, we just have a 1 up there. Okay, so think about where are there more. If you'd like to write out the r's, you can. And then you're going to cross out if they're the same on the top and bottom, and there's an r on the bottom. So, this is what I have left when I simplified my two separate parts of this problem. So now I'm just going to kind of stick them together again, and I'd have like 1 times 1 on the top is just going to become a 1. 2 times r on the bottom is just going to become 2r. So here is our simplified version of this problem. So really there was only an r that simplified out. Okay, here we're going to do one more example that's definitely a little bit more difficult. We have a lot of variables and we have letters, or a lot of numbers. So I'm going to separate each individual part. So I'm going to have my number 4 thirds. Then I'm going to just write the m's. M to the 4th over m squared. Then I'm going to write next my n's. N to the 3rd over n squared. Last are the letter p to the 3rd over p to the 4th. So I'm going to think about each of these as a separate little problem. Okay. So with my numbers here, again, I want to divide them, but I don't want a decimal. If you take 4 divided by 3, you'll end up having a repeating decimal. So I'm going to leave this as 4 thirds. Just going to bring it down. That might happen. Okay. If they were bigger numbers, you might want to reduce the fraction to get to a smaller fraction, but you might still not you might still get a decimal, so keep it as a fraction if necessary. Now let's look at our m's. If I write them out, if I have m, 4 m's on the top, 1, 2, 3, 4, and then I have 2 on the bottom, 1, 2, and I cross them out. If they're the same on the top and bottom, I have 2 on the top still. So I have 2 m squared on the top, and remember there's a 1 on the bottom. I can't write it as a 0, but it's a 1. Next, let's look at our n's. So I have 3 n's. I have 2 down here. I can cross them out. If they're the same on the top and bottom, I have 1 n left on the top, and just the number 1 we'll put on the bottom. Last, we have the p's. 1, 2, 3 of those, 4 of these. I'm going to cross them out if they're the same on the top and bottom. So I have 1 p on the bottom remaining. It's very important if it's staying on the top or the bottom, the numerator or the denominator of the fraction. So here's what we have with all 4 of our separate parts simplified. Now I'm just going to squish them all together. Okay? Just going to squish them together. So on the top, everything that I have on the top of each of these individual fractions is going to become the top of one fraction. And I have 3 times 1 times 1 times p. So the times 1, that part doesn't really matter a whole lot because that doesn't change it. So I really have just 4m squared n over 3p. That's our most simplified form of the original problem. So separate them into the numbers, the big numbers in front, the coefficients, and then the variables, and then in the end you'll just stick them back together at the end. So this was simplifying expressions when they were in a division type of problem.